Hey you guys, I'm going to be quickly going through an acid-base neutralization problem that is a good way to study for your final exam. If you go ahead and look through the text of the post where I have this video posted, you'll see all the numbers and stuff that we'll be doing for this problem. So I'm going to save just a little bit of time by hopefully having you read that first so you have a good understanding of what we're going to be doing with this problem. So in this problem, we have an acid-base neutralization reaction. We have sulfuric acid reacting with sodium hydroxide and neutralizing each other. And what we're asked to find the concentration of sulfuric acid. And what we know is that it took 3.6 milliliters of a 0.65 molar sodium hydroxide solution to neutralize 5.5 milliliters of sulfuric acid. So we're going to be trying to figure out what the concentration of sulfuric acid was. And one of the things that we're going to do first is we're going to think about the units of molarity. Molarity is equal to moles per liter. And this becomes really important because this is in units of liters here, but both of our units given here are milliliters. So we're not going to be able to directly use those volumes. So the first thing I actually want to do in this problem is convert both of these volumes into liters so that we can just use those numbers later. So we have 3.6 milliliters times 1 liter over 1,000, because there's 1,000 milliliters in a liter. This is those kind of conversions that you learned early on in the class and that hopefully you still know. So this is equal to 0.0036 liters. And the next is 5.5 milliliters times 1 liter of 1,000 milliliters. Makes us equal to 0.0055 liters. So this is for the NaOH, and this is for the H2SO4. So that's just one easy step that's going to save us some headaches later on. So the next thing we want to do is we are going to try to solve, we're going to solve for the moles of NaOH here. And we're given the amount of information, we're given the volume and the molarity. And you can, using the volume and the molarity, you can solve for the number of moles because molarity is moles per liter. So I'll show you how the units of this work out. So we're going to solve for the moles of NaOH. And how we do that is we take the molarity, which is 0.165. I'm going to write out moles per liter. And so we're going to try to get the liters to cancel out because we want the moles to be left over. So all we're going to do is we're going to multiply this by the volume, 0.0036 liters. And as you can see here, the volume, the liters on the bottom and the top are going to cancel. And if we do this on our calculators, what we get is 5.94 times 10 to the minus 4. 5.94 times 10 to the minus 4 moles of NaOH. So that's one easy way to do if you're ever confused on these acid-base problems. First thing to do is look and see if you can solve for the number of moles of something. And if you're given a volume and a concentration, all you have to do is multiply them and you get the number of moles. So the next thing we're going to do is we can take this moles of NaOH and we can use our chemical equation to solve for the moles of sulfuric acid. So I'm going to now do that in a different color. So there is a 2 here in front of the NaOH and there's a 1 in front of the H2SO4. So we have 5.94 times 10 to the minus 4 moles of NaOH, and we multiply that by the fraction. We have 2 moles of NaOH for every 1 mole of sulfuric acid. Okay, so we're basically just going to divide 5.94 times 10 to the minus 4. We're going to divide it by 2, essentially. And what we get is 2.97 times 10 to the minus 4. So I'm just going to write that here, 2.97 times 10 to the minus 4 moles of H2SO4. So now we've gone and we figured out the moles of NaOH, and we use the chemical equation to solve for the moles of H2SO4. So our last step is we have the moles of H2SO4 and we have the volume, so we can just divide them and you get the molarity. So the last step is to take, we're going to solve for the molarity of H2SO4. Oops, H2SO4. So that's moles per liter, 2.97 times 10 to the minus 4 moles per liter, because we can't just use this 5.5, because that was in milliliters. We have to use this volume, divided by 0.0055 liters. If you do that on your calculator, you get 0.054 molar equals 0.054 molar H2SO4. And that's exactly what we were looking for. We were looking for the concentration of sulfuric acid that was neutralized by this particular concentration of sodium hydroxide. So this kind of question, the hardest part I think was actually doing the conversion here, because they weren't in a 1-to-1 ratio. They were in a 2-to-1 ratio, which you would find from the chemical equation. So hopefully that cleared up some confusion for anyone who's been having difficulties with the acid-base neutralization reactions. And always let me know if you have other questions. Thanks for watching, guys.